Right then, this is the automatic test equipment. Okay, over here. Right, these are the storage areas for the LIUs coming in and the LIUs going out. And this is a special handling area. You've heard of static control? I don't know why it's suddenly so important. Do you know, I've been in for 25 years and I've yet to see a problem you can put down to static.
Wait a minute. Yes, I said wait a minute. You know that electronic circuits are getting more powerful and compact. Well, the active areas on a microchip are so small that you can really only see them with a powerful microscope. Have a look at this. This is magnified by about the same amount as being able to see a car from a satellite. These devices are so tiny that they cannot handle any current or voltage much greater than the normal operating levels. With an electrostatic discharge, or ESD, a current of tens of amps or more can pass, if only for a very short time. And this current can damage the circuit in the same way that an overcurrent would blow a fuse. By the same means, all kinds of damage can be produced, such as holes or bridging, which can have intermittent effects, especially with vibration or temperature changes during operation. It may even be the cause of all those no-fault fouls you've been putting down to those idiots on the line, or aircrew finger trouble.
I can see what you're saying, but...
Electrostatic damage can occur to a device from voltage levels far below those required to make a spark, and the technician won't be aware of the damage caused.
I can understand that too much current can blow a circuit, but where does the current come from?
Come with me. Watch that screen. All materials contain electrons which are negatively charged, and an equal amount of positive charge which makes the material electrically neutral. Dissimilar materials contain different numbers of these electrons. When placed in contact, electrons come into equilibrium where the materials touch. To do this, some electrons have to flow from one material to the other. And since they're negatively charged, this leaves the materials with equal and opposite charges. Exactly the same thing happens every time your feet touch the floor. As the body is a capacitor, with every footstep you acquire more positive charge and the machine acquires more negative charge. If this process continues, a level is reached where a spark can be produced to anything at a lower potential.
Oh! Sorry now! Okay. But I've never felt anything like that when I've been working on equipment in the bay.
Aha! The point is that you'll only feel the discharge if you're above 2 kilovolts. Devices can be affected by much lower voltages than that. I'll show you. Touch that probe. Now you're at 2 kilovolts, but you can't feel it, can you?
No.
Now touch this earth.
No fear.
You won't feel a thing. I promise.
It's all right.
But the discharge was there. Now touch the keyboard and do it again. Digital systems work on pulse trains, and an electrostatic discharge, even if it doesn't damage a device, may well be interpreted as a signal pulse. Now do it again. In the worst cases, an electrostatic discharge will cause a system malfunction.
But I didn't feel a thing.
I told you.
Okay, so I can charge up and I see how that can cause damage. But what can I do about it?
Well, electronic equipment has to be handled in an area where everything is at the same potential. This is achieved by using proper work areas and using the right procedures.
You mean use a special handling area?
That's right. This is a workbench which is covered with a charge-dissipating surface, connected to ground via a common reference point, which also serves to ground wrist straps for the operators. All vulnerable items are specially packaged and should only be opened on the bench, so that everything is at ground potential. A Type 1 special handling area has mains power provided to it via a residual current device. Any bench lighting or soldering irons used should derive power from this source. The bench is used for the full range of tasks, such as component replacement, module rework, or programming of memory devices. The Type 2 special handling area is essentially the same as the Type 1, but has no power supply and is intended for the unpacking of equipment containing ESSDs, replacement of subassembly and PCBs, and repackaging. But the important thing, of course, is how they are used. The operational procedures for both types of special handling areas are the same. The most important is the grounding of personnel via the wrist strap before even approaching any exposed and vulnerable circuits.
That's fine, but I don't fancy being connected to ground when I'm using mains-powered test equipment.
No problem. There's a 1 megohm safety resistor incorporated into the ground cord. Currents greater than a few milliamps are harmful, and the resistor will limit currents to well below this level.
Okay.
The integrity of both the grounding connection and 1 megohm protection resistor must be confirmed by using the wrist strap monitor every time before use. This ensures the safety of both the operator and the equipment. The wrist strap should be tested after finishing as well to confirm that the work was safely completed.
Are there any other pre-use checks?
Yes. Make sure that the bench mat is connected to the common reference point and that the mat and all connecting leads look in good condition. With the Type 1 SHA, you need to test that the RCD is operating correctly. Monthly detailed inspections will check that all of the equipment is actually okay, and should any surfaces need cleaning, use only those materials approved for the job. Don't forget to check for extraneous plastics and other possible sources of static charge, and also to ensure that personnel who are not earthed do not approach the bench, regardless of their rank.
How's it going, Chief?
Up till now, fine, sir.
Fine. Well, this is 1771. I've signed it for you.
Thank you very much, sir.
Okay.
That's all very well while I'm in the bay, but what happens when I'm on detachment? I can't take my bench with me, can I?
This is where the field service kit comes in. The field service kit is a portable special handling area which provides a dissipative work surface with wrist strap and ground cords. It can be used as temporary protective packing for ease of transportation. It allows freedom of movement and is not restrictive in any way. You could actually use it here, where a quick circuit board change is needed at the test station, for instance. Just make sure it's grounded. But it comes into its own in those large installations such as flight simulators, ground radio, or radar situations, or Rapier.
I don't suppose it makes any difference if I wear barrier creams.
No, not as long as the strap is making good skin contact. And don't forget that the wrist strap and lead should also be tested regularly before use.
Right then, let's just see if I've got this straight. ESD can damage electronic circuits, and vulnerable items are specially packaged. But ESD can be eliminated by working at a special handling area or by using a field service kit. And you must carry out pre- and post-use confidence checks.
Very good.
I think I'd better try again. Right, here is the special handling area. This is very important these days. You know that if we can avoid static damage, we can improve the reliability of the equipment and increase the availability of the aircraft. Storage areas for the LRUs coming in and going out.